Hello, welcome to another WEBSEC.fr. Today we're going to be doing level 10, which is right here. Awesome file downloader. So you give it a file name, and as long as the hash is correct, it'll show it. So here we have index.php, and they provide both these for you. You didn't have to enter them. But yeah, that's the actual file. We could also look at the source code here, but since it's right here, let's just take a look. The main thing you're going to be looking at in this is that it takes a hash, hashes it, or it takes the hash value, as well as the file name, and it kind of just compares the request to the actual hash of the file, as well as the flag. And if they're the same, that is, if this hash matches whatever hash they have on their side, it'll give you the file. So the idea here is that PHP uses this loose comparator, this double equals, and there's some weird things that happen when you use that. There's actually a cool, there's this OWASP site link. I'll put this in the description, I guess, but this kind of explains it in a bit more detail. The main gist of it is, though, when you're using this equals comparator in PHP, it can sometimes treat those hashes, this is some sort of hash, this is a different one. If the first value is a number, it'll treat it as a number, and it won't look at anything to the right of it. So it's literally just checking the 0 and the 0, and in this case, it'll evaluate the true. Similarly, it can also, again, if the hash looks like hex 0xf, that's 15, it'll evaluate it as hex, again, 15. This reminds me of some sort of like JavaScript weird stuff that goes on when you compare. But yeah, that's how we're basically going to be kind of just basically brute forcing the hash in a way. But this allows us to brute force it a lot faster, although it still does take time. So right over here, what we want to do, since we don't want to do this, manually, we could go ahead and open up Python, import requests. This is the prefix, and we are, again, we're looking for, obviously we're looking for the flag. So flag.php. This is what it gives you, actually. So you know exactly what you're looking for. You're just looking for the hash. And we give it the data. We give it f, which is a file name, which is flag.php is what we're looking for, and this hash. The interesting thing about this algorithm is that the hash stays completely constant at all times. The thing that we're actually going to be changing is flag.php, but not really. It's still going to be the same file. We're just going to be appending these slashes at the front, which, if you go ahead and open up your local WSL, let's go ahead and cat link.c. Let's see what we get. Very simple C file. Let's cat /link.c. That should return the same thing, and it does. Now let's return // just a bunch of slashes, link.c, and see what happens. It actually returns the exact same thing. So you could have an arbitrary number of slashes in the beginning, and it should return the same file. So we're going to be kind of abusing that. And if you think about it, we're technically changing, what the f is, right? It can be flag.php, or it could be / flag.php, so on and so forth. And you just have to remember there's a dot in the beginning too. Eventually, it's going to have a hash not exactly matching this, but it's going to have a 0 in the beginning. And it's going to eventually evaluate that hey, since the 0 is here and the 0 is in the actual hashed value, it has to be the same. And it's going to give us the flag. Now we can run this, but since we are like kind of brute forcing it, it still will take a while. I'll put the code in the description too, because, but here's actually the output after a few minutes. And right at the bottom, you get the flag. So there you go. A little bit of a PHP fault, a little bit of a cryptographic fault, but in the end, we were able to compromise the system.